And thank you for the opportunity to present. I think the foreword or the introduction by Tobias was suits well with what I'm going to present. Can you see my presentation? Great. Yes, my name is Martin Lundborg. I have two hats on. I'm working for a research institute as an economist. It's called VIC. We are doing research on digital transformation from a business and economics point of view, and looking on how to promote digital technologies. I'm here today, as Tobias said, for Mittelstand-Digital. It's a program funded not by the Ministry for Education, but for the Ministry for Economics. But that's just a small detail. Here I'm responsible for the accompanying research, and we also do public relations work, networking, and I'm representing this network as well. So today I wanted to present our definition and understanding of what digital production, digital manufacturing is. I also wanted to explain what we do at Mittelstand-Digital. And at the end, I also have brought with me 5 use cases, which I think is a very good way to show how or what digital manufacturing really is. So what is digital manufacturing and what is the current state in SMEs? So I'm from Germany, and I'm actually originally from Sweden, but I live in Germany for 20 years. And our perspective is also based on this business model which the German economy has. So we are an economy with a lot of so-called hidden champions. We have a lot of small and medium-sized enterprises acting in the field of manufacturing. These are very often family-owned. We have a large number of manufacturing companies with between 50 and 250 employees working in integrated value chains, for instance, for large manufacturing companies like BMW or Daimler or Volkswagen. So this is more or less typical also, or I suppose, the structure you will find in some Eastern European countries, which are also producing parts for the larger OEMs. The German government has started Mittelstand-Digital and other programs because we know that the SMEs are really lagging behind the large corporations. So if you look at, for instance, the use of artificial intelligence in Germany, the smallest companies with up to 9 employees, of them only 13% are using AI technologies. If you look at the larger SMEs, like 50 to 250 employees, the statistics says about 15% are using artificial intelligence. But of the large companies, there are 30%, about a third using artificial intelligence. So that's some figures showing how SMEs are lagging behind. This suits good to your question before, if SMEs are lagging behind. I think that's what we see. Problem is also if you compare investments in manufacturing with investments in other areas of the companies. So for manufacturing, we see that the larger companies are investing more, but it's still something that needs to be improved. I saw figures on investments of that 25% of companies are really investing in digital production, and in marketing and administration is more than 30%. So we also need more activity from the SMEs. They need to scale up their investments. There is, when you come to manufacturing and digitization and digital transformation, there are some things you have to consider when companies are starting to invest. First is you have very long depreciation times. You don't build a factory for 2 years or 3 years. If you buy a machine, it's going to be there for 20 to 30 years. So we have very long investment spans. That's also why it takes longer time for manufacturing to digitize than other sectors. But it also means when companies are investing, they are more cautious. So that's why it takes longer time to convince people or convince companies to invest in digitization when it comes to production. We also have more complexity and also more integration. It's more complex. So and that's why it's difficult and takes time. But we are on the right track. I always like to use this picture because it shows a little bit where the way is going. And on the very left, you have Industry 1.0. That's the production we had 200 years ago. No companies in Europe are on this level. And then you have Industry 2.0 with mass production. Everybody has heard about Ford and his production lines 100 years ago. And then we have Industry 3.0. And that's something that came up last century with automation, computer and electronics. Many robotic companies were founded in the mid-1900s. And here we have a lot of companies of today. So very many of the companies we're working with at Mittelstand-Digital, they have some kind of automation, they have machinery, they have computers they are using, but they haven't taken the last step to Industry 4.0. And the difference between 3.0 and 4.0 is that with 4.0, you have all machinery connected to each other. So you connect every machine and every part of your process. You integrate into a digital platform like a manufacturing execution system and MES or the OT, or you connect it with your customers or with your suppliers. So here you have all the IoT equipment, connections and standards, etc. And here we see that companies, on average, they are advancing, but it's still we're still at the beginning. I think the usage of IoT in the German industry is about half of the companies are using IoT, but especially if you go to companies below 200 employees, the usage of IoT is still rather limited. And we also see when the companies are moving from Industry 3.0 to 4.0, the problem is that many companies are still struggling with the ERP systems and MES systems. So they haven't really, they have problems really with the connectivity and the basic digital functions in the factory. And the things we're looking at in the future with artificial intelligence, intelligent robotics, etc. These are more of a vision for many for the most SMEs, as we know. We also, when we look at Industry 4.0 here in this picture, it's not that clear what it actually is and where we're heading. The term was founded 12 years ago in 2012 on the trade fair in Hanover, as I know it. At the beginning, there was a huge confusion. What is it actually meant to be? And then they started developing some ideas. They come up with the RAMI 4.0 and started to think about standardization. And that's when the administrative asset shell was invented. And now we're creating these standards. When we come to year 2024, we see that we've come pretty far when it comes to standardization. We now have standardization units like IDTA, providing administrative asset shells, which are standards for how to save data and how to store data. And we also have communication interfaces like MQTT and UPCOA. So we start now to have the standards, and we see of the many companies who are now advancing in Industry 4.0, they're actually starting to implement the administrative asset shell. That is, they're now starting to collect and storage the data in a standardized way. And this is very important because first, when I have standardized data, you can exchange the data between machines and with your suppliers and customers. But Industry 4.0 and the standardized exchange of data is not the end. The next step will be the data spaces like Manufacturing X or Catena X. But this is still the future. The prototypes are being developed. So that's nothing that really SMEs have implemented today. This is the vision for the future. But as of today, most companies are still implementing the basic IoT technologies. I will come to some use cases later, which are really showing what I mean by this. So from Tobias, we had a definition for digital manufacturing. Here's the definition from the platform Industry 4.0 from Germany, which is more or less saying the same. Industry 4.0 refers to the intelligent networking of machines and processes for industry with help of ICT. And we have a lot of technologies listed here on the right side. But boiling down to what it really is about, it's about interconnecting and using the data in the production. Yeah. I think important when you look at digital manufacturing to better understand. In our work, we have seen that it's important to think about which roles, because now when we start exchanging data, we're building a complete data layer over the former or the traditional manufacturing. And with this new layer, we get a new ecosystem. And we have three main players in this ecosystem. We have the providers of machinery. These are the ones producing the machines. And they are pretty far when it comes to Industry 4.0. They are now starting rolling out their products with data interfaces and with integrated IoT technology. So if you now want to buy a machine, you can get it from Bosch or Siemens or one of the smaller providers. And there you have the possibility to add digital parts to your machinery when you buy them. But in manufacturing, at least how is it in Germany, is that every manufacturer is doing his own thing. So you can't just buy a machine, put it in your factory and start producing. Everything is very customized. And therefore we need the integrators. The integrators are those implementing the machines, implementing the software on the shop floor. And at the right side, we have the users, and these are the producing companies. They can produce some parts for the automotive industry, for instance. And these users need the integrators, someone who comes with them and implement everything into the system in the factory. And the digital transformation is very different, advanced in these three companies. The providers are pretty far. The integrators are typically IT companies, which in the manufacturing area, which are really digitized, but the users are mostly on the very beginning of digital transformation. Yeah, I have some data here on digital manufacturing, which we have gathered. It says what I said before. Here it says a survey by the Institut für Mittelstandsforschung that 43% of the companies surveyed see themselves as laggards in the network production. 36% of companies use Internet of Things. That was in 2021. That will be higher now, but we still see about half of the companies not using it. 22% of the SMEs surveyed have clear goals for the Industry 4.0, and this shows also that many companies don't really know what digital in manufacturing really is and what's the future outlook for digital manufacturing. I asked some of my colleagues, some of our experts in Mittelstand-Digital, what's the problem, what's the challenges for small and medium-sized enterprises when they want to digitize their manufacturing. And in discussions we had, we found three main issues. You can define them a little bit different, but the first one is human resources. Many small and medium-sized enterprises don't have the skills and the know-how, but also the acceptance of the employees is something we discuss a lot. Many employees in the SMEs are afraid of losing their workplaces. And it's very important to align everything you do with your employees and the representation of your staff. Because this lack of acceptance can really block projects. And yeah, by the way, we have a huge problem overall in Germany when it comes to digital transformation projects, that many of them are not successful and not finished. That was a study by KfW, not only for manufacturing, but for digital as a whole. We have a pretty high rate of unsuccessful digital projects in Germany. That's something that has to be improved. Yeah, also important to address these acceptance problems is to have quick wins. So we always try to implement small projects and focus then on change management. The second area, which is problematic, are the financial resources. It's very difficult when it comes to digital projects to grasp what's the return on investment. And you typically have high initial investments when it comes to manufacturing. Here it's important that you divide up digital projects into small projects and stage them in steps so that you can take one step after the other and don't have to invest everything at once. Not to forget is many of the SMEs only have one factory and a few machines. And if you do digital projects on the shop floor, this is happening as long as simultaneously with the day-to-day production. So interruptions to the productions are very costly. So companies are also very cautious when they implement digital transformation projects on the shop floor. Yeah, and one solution we have found to convince the CEOs and to convince SMEs to invest in digital transformation for production, it's to show best practices, show what other companies have done successfully, and also show what they've learned from these projects. So a short overview of my initiative, Mittelstand-Digital, has been founded by and supported by the Ministry for Economics. We have now 29 competence centers all over Germany. About 15 of them are working with manufacturing issues. Each competence center consists of experts from academia, from academic institutions, universities, etc. But we also have in every center, we have one partner which is also bringing a business network. Because you need a business network in such a project to align academia with the SMEs, because SMEs are reluctant and don't know about what is happening in the academic world. So you need someone to bridge the gap, and therefore we will have like trades, commerce, and different industry organizations are also part of these Mittelstand-Digital competence centers. And an important aspect as well, when we talked about what's the cool new digital technologies for manufacturing, a very important issue is IT security, cybersecurity, and safety issues. And we also have issues like legal issues. We have the new Data Act coming up in a couple of years. It's going to be implemented, and legal and IT security, cybersecurity are also important issues when we talk about digital manufacturing. Yeah, here you have a map of our competence centers over complete Germany. And what are these centers doing? They provide expert knowledge. So we have information events, we have meetings with SMEs. They can come to the centers. We also have demonstration centers like smart factories and demonstration factories, where the SMEs can look at how digital solutions are implemented. As I said, we also provide best practices. What's the use cases? And we show use cases which has really been implemented in the companies, so that the CEOs then have trust in that these best practices are also working. And very important for the work we are doing are the business networks we have, because CEOs like to hear and know what other CEOs are thinking and doing. They want to see what other companies are doing. That provides proof that the digital transformation is working. So the business networks are used also to reach out to the companies. And this is, according to my point of view, the most difficult thing when you have an initiative like ours, is to actually reach the companies who are out there with your offerings you have as a publicly funded information initiative as we are. So last part of my presentation, I wanted to show some use cases. We have first to look about a little bit what can you do with digital manufacturing. You have flexible production and dynamic production. Here we talk of using data, monitoring and steering your machinery. Customer-centric solutions like having a one-lot production, customization of the products, so that each customer gets the product he really wants. We have logistics like AGVs and more transparency, so that we can companies can reduce their warehouse costs and more efficiency in the logistics. The use of data to provide transparency and predictions about future productions, or finding anomalies in the production to improve the quality of the products, for instance. And last but not least, what we are discussing a lot in Germany now is that the legal regulatory space is really driving digitization. because with the new legislation we have on, for instance, the supply chains, Lieferketten-Sorgfaltspflichtengesetz in German, here the companies are forced to provide information about their suppliers. We will in the future also have more transparency with regard to sustainability. This is actually addressing the larger companies, but as the larger companies are forced to provide reporting on carbon footprint, etc., these are also passed on to the SMEs. So the SMEs are also forced to provide much more data, and I think a lot what we here see is about energy consumption and carbon footprint. And here digital transformation technologies with IoT to measure the use of resources is something that is really pushing companies to invest in digital transformation. We had a project where we gathered different best practices, use cases. I wanted to show you 5 of them. We also tried to state which digital maturity the projects had. So from 1 to 5. So the projects with a 1 is projects which are easy to implement and not demanding so much of the companies. And I would like to show a couple of them from the easiest one to more advanced. So here we have best practice from a company called Friedrich Binder. They're producing jewelry, gold and silver products in Baden-Württemberg, 150 to 200 employees. And this was a very basic one where existing machineries, which are sometimes very old, they have old interfaces, and the challenge is then to connect them and get monitoring data for these machines. So here in this project, Friedrich Binder implemented digital sensors with IoT technology, and now they can view their energy consumption in real time and recognize when energy is wasted. And this is a very simple way of using digital transformation to improve your profitability and your competitiveness. And really bringing sensors to machinery is so easy because you don't have to change the machines, you don't have to invest a lot, you just add the sensors to existing machines, you connect them to your IT system and start monitoring. So this is something that is small in investment size. You can do it quickly and you can provide things you can see the data very quickly. So this is a good project to start getting the first step from Industry 3.0 to Industry 4.0. Here we have another example, which is a little bit more advanced. 2 or 5, not so very advanced, but waste reduction is a very important issue for a lot of manufacturing companies because waste is expensive and it's not good for your sustainability reports, and it also costs money because you need more resources than necessary. So here we have a company called Stüber. They're also in Baden-Württemberg, a manufacturer of textiles. By the way, Germany is one of the leading companies worldwide in producing textiles, not the textiles we are wearing, but industry textiles and smart textiles, etc. is something where Germany is really well ahead worldwide with many hidden champions, and Stüber is one of them. And here the idea was that they have in the production, they have the yarns and they run out in the middle of the process, and textile manufacturers therefore normally change the yarns before their end of lifetime. And therefore they waste a lot of yarn, which is then disposed. And with digital technology, integrating sensors into the processes, can detect the amount of yarn remaining on the yarn, and then they change the yarns only when they are empty and not before. So here you can save waste and then also save costs and have a higher sustainability. And here you also need just monitoring equipment. A third example is Spray. They are producing lifts for buildings. Manufacturer in Schleswig-Holstein in northern Germany, 50 to 150 employees. And they had the problem, and this is a huge problem in Germany, that a lot of people are now going into retirement because of the demographic changes, which was also mentioned at the beginning of this call. And the idea is to use augmented reality to train the young new employees and to transfer the knowledge from the older employees to the younger employees. So here they're using augmented reality to guide the younger employees when they are using the machines and when they are doing repair tasks. So when they see there is a problem with the machine, they can put on their augmented reality glasses and get then instructions on how to repair the machines. These kind of augmented reality projects are a little bit, well, I'm asking myself sometimes if these are the future, because you have a lot of costs for programming the software and getting all the instructions. So this is something which is profitable if you have several employees doing the same task and needs the same kind of training. So the first two best practices I had was about monitoring and measuring, and we had one on on augmented reality. But when you wanted to build a real digital production facility, you want to have an integrated system combining all the machines you have, building a complete model. And here we have an example from Vision Laser Technique. They are using IoT technology. It's a milling machinery technology company. And they optimize the utilization of the machines by putting IoT equipment in all machines, bringing them together in an MES system. And then they use also artificial intelligence to optimize the processes on the shop floor and minimize idle times of the machine. And they also use this system to place new orders. There is a just-in-time system, and therefore they reduce warehouse costs. And here you can also see it's really getting complicated when you have a lot of machines, because normally in a factory you have machines from different decades with different interfaces, different state of technology, and then you need to retrofit them, put modern connectivity equipment on top of them. And this is costly because you have, sometimes you have to do it for every machine. So it takes a lot of hours to program the interfaces and to bring all the machineries together in one IT/OT system. And the last one I have is the most advanced. For today, it's about digital twins, that was mentioned as well before. And here, of course, you have to do everything we did before on the other projects. You need the IoT equipment, every machine, and then you can start thinking about developing a digital twins. We have a company called Kreinberg, which is very, very advanced, one of the hidden champions in Germany. And they use they're doing then 3D digital twin for their products, which are then used in their CNC machinery. And this shows when you have digital twins, that's when you can start thinking about implementing digital product passports and show, start modeling your whole production and implement a future production facility. But that's more advanced than what most companies have today. So to summarize, I think I'm a little bit over time, but to summarize some things, digital production is something that's for the future. But we have a lot of research still to do, especially the next step when it comes to data lakes, data rooms. And the SMEs are lagging behind, and you have to show SMEs the way forward by, on one hand, show the vision of a future digital production. But for the SMEs, you first need to convince them with small projects, bringing sensor IoT equipment into the production one step at a time. And then you can convince the employees and the CEOs to continue the digital transformation. So start small, in small steps, convince everyone, do a lot of change management, show the usage, and then we will end with a future digital production.